Hello, I heartily welcome all the viewers to watch this video. So first of all, let me introduce myself. I am Harsh Sidpura and currently I am pursuing Information and Communication Technology, Bachelor of Technology at Marwadi University. So uh, today we are going to discuss about my project that is a part of my digital electronics subject, and also I have combined this project with engineering design and computer aided design project. So let us start the video. So the subject name is digital electronics. Alarm circuit. So I am making this project of anti-theft alarm circuit. So actually, this would be working as an anti-theft alarm. So some of the glimpses of my project are what are its applications. So let me start. So you can use this anti-theft alarm circuit to thwart burglary. It sounds an alarm when someone tries to intrude into your home or office by hitting or pushing or knocking the door. This is detected by a mic and fed to the preamplifier section of the circuit, which is connected to the buzzer through flip-flop. Thus, the buzzer sounds when someone hits or knocks at the entrance door. So, in this whole project, the what is the we could say that if anyone knocks the or hits the door, then there would be turning of the on of the buzzer and the LED. Now, this is a block diagram of my whole project. So my whole circuit is divided into these three blocks. The first block is pre-amplifier. This is the pre-amplifier block. The second one is flip-flop. This is the flip-flop block, and the last block is power supply. Now, this is the block diagram. That is a flow of the circuit. So this is any one person when the person knocks the door. So there would be a condenser mic that will receive the knocking. Now this whatever the signal that is produced by this condenser mic would be fed to preamplifier. This preamplifier block would amplify the signal. This is the amplification of the signal by the use of transistors. There are two transistors that I have named it as T1 and T2, and this signal amplified signal would be fed to the flip-flop, and this flip-flop would be controlled by the power supply. Now according to the output of the flip-flop, there would be glowing of the LED and the turning off on and off the buzzer. Now working of the whole circuit and its principle are, let me discuss more in detail. So in the pre-amplifier section, transistor T1 and T2 amplify the signal received from the condenser mic developed during the knocking. The output of the pre-amplifier is used to clock the JK flip-flop, that is this IC we are using, that is CD4027. In the JK flip-flop section, the dual JK flip-flop, that is CD4027, is employed, and only one of the two flip-flops is used. So in my circuit, there are actually two flip-flops, but we are using only one of them. The flip-flop is inhibited when both the J and K are low. The K input, that is pin 5 of IC, is grounded, whereas J input, that is pin 6, is connected to the Q, that is output pin, pin 2. The output of the preamplifier is connected to the clock of pin 3. The amplified signal is fed to the JK flip-flop as we have discussed in the block diagram. Once this flip-flop receives the input through the condenser mic, the output goes high and remains high until it is reset through the switch SI. The output of the IC1 drives buzzer PZ, that is piezo buzzer, via NPN transistor, that is T3. We'll see more about this circuit in the later video. And now, so the buzzer sounds when someone knocks at the door. It remains on until you press the reset push to on switch S1 at pin 4 of IC1. To sum up, the sound produced in front of the condenser mic is amplified and used to trigger the IC1. Thus, the buzzer sounds until it is reset. At the same time, LED 1 glows to give visual indication. Now, circuit diagram. Now we are going to see the circuit diagram of my project, and we will discuss the flow of the circuit. So this whole circuit diagram. Now, as I told you before in the video, that the whole circuit is divided into three sections. There are three blocks. That is preamplifier, the flip-flops, and power supply. So let me tell you this. Starting from here, and these all are included in the preamplifier stage till T2. That is this whole capacitors, resistors, and T1 and T2. This whole part. This part is included in the pre-amplifier stage. Now, whatever the amplified signal is there is fed to this IC. This IC comprises of two JK flip-flops. Actually, there are 16 pins in this IC, but that is comprises of two JK flip-flops. So there will be 8 pins for one JK flip-flop and another 8 pins for another JK flip-flop. But as we are going to use only one JK flip-flop, so we are using only 8 pins of this IC. Now the output of this IC is connected to the this is the T3 transistor, and there is buzzer and LED. Now according to the output of this IC, that is flip-flops, the LED would turn on and off, and the buzzer would be uh, start ringing. Now the whole circuit is fed with the power supply. This is a whole power supply. So in power supply, this is the transformer. Now this transformer, whatever the AC signal is coming, it is converted into the DC signal, and this IC, that is 7809, regulates the voltage to the 9 volt. So whatever would be the input voltage, that voltage would be converted to the 9 volt DC, and it would be supplied to this circuit. So this was the brief explanation about the circuit diagram. This is the condenser mic. These are the transistors, that is T1 and T2. This is the IC comprising of flip-flops, there is buzzer and LED, and this is the power supply of 9 volt, that is converter IC. Now, coming to the components that are used in these circuits. So, how would be the actually looks of these components that are used in the IC? So, let us see one by one of the components. So, this is the first IC, that is CD4027, that comprises of two JK flip-flops. So, these are the 16 pins. The 16 pin is here, and the 8th pin is here, and these two are the JK flip-flops, and this clock are there, two clocks are there, but in this circuit we have used only these 8 pins in our circuit. These pins are unused in my project. Now let us see more about this IC. So the architecture of this IC, that is CD4027, is a JK flip-flop that is generally used for data storing. Two similar or equal JK flip-flops are contained in the IC, as I have told you before that two JK flip-flops are present in that IC. Each pair of JK flip-flop with IC has provision of pins J and K, set, preset along with clock, and with two output terminals which are complementary of each other. JK flip-flop can be employed in the applications like voice registers, counters, or else control circuits. So these are some of the applications of JK flip-flops. Uh, those are registers, counters. So we could make this uh, circuits using JK flip-flops. Now coming to the voltage regulator IC, that is 7809, which converts the any power supply to the 9 volt DC supply. These are the three pins of the IC, that is V in, ground pin, and V out. Here in V out we'll get 9 volt DC supply. Now we have used condenser mic in the IC. So whatever the noise that is produced by the any human, that would be fetched by this condenser mic through this. The some of the other components that I have used in my project are RS. These are the transistors, that is BC547 and 548. Actually, we have used two BC547, that is T1 and T2, and 548, that is transistor 3. which in my project this transistors, that is 547, would be acting as an amplifier transistor, while this 548 would be acting as a switch according to the output of JK flip-flop. Now these are the resistors and capacitors that I have used in my project. These are the LEDs and the buzzer. And this buzzer would be ringing until we press the reset button. And these are the LEDs. Now output. So what would be the actual output of my project? So if there is some noise, means any particular noise that is above some of the range. So if it is fetched by the condenser mic, then the buzzer will start ringing. So buzzer would be ringing and LED would also be start glowing till we don't press the push button. So until we press the push button, the buzzer would be ringing continuously and LED would be glowing. When we press the push button, so all the signals would be reset and the JK flip flop would be in the reset condition, and buzzer would stop ringing and LED would be off. Buzzer and LED would stop after pressing the push button. Now, let me discuss some of the troubleshootings and the problems that I faced during making this project. So there are many situations through which I was unable to get the solution. So these are the troubleshooting tips that I applied, and I was able to give a glance and better view to my towards my project. So the first and the main point is checking the voltages at different points. Now this is the major and the most important point, because if we are able to know the voltages at different checkpoints, so we could check this that we are getting the correct voltage at the particular point or not. Now testing mic in CRO. Now when we buy a mic from any store, so we don't know that the mic is in the proper condition or not, so we need to check this mic in CRO, that we are getting proper signals or not according to the our input. Now this is the major drawback of all the ICs, that we need to check all the pins of the ICs. When we buy any ICs, the first and foremost thing that we should do is check the pins, all the pins of that IC. Now as there was potentiometer in my circuit, so we should also check the outputs by varying the values of the potentiometer. Now checking the correct amplification of the preamplifier. So in my circuit it was important to give the amplified signal to the JK flip flop, so we need to check that we are correctly amplifying the signal or not. Now we are going to see the model that or the project that I have uh, made using as a EDCAD, that is engineering drawing, and computer aided design software. So I have put all the circuits and kept in that snap box in that particular model. So this is my project model. So you can see the whole model. So let us first of all focus on our circuit part. So as I show in the circuit diagram, so this is the condenser mic, this is the potentiometer, this one, and this is the buzzer, and this one is the LED. Now this is the reset button. So once if there is a noise or the knocking of the door, so the buzzer and the LED starts glowing and the buzzer starts ringing till it rings until we press this push button. When we press this push button, so the flip flop gets reset and buzzer and the LED stops glowing. So this was a part of that digital circuits. Now focusing upon our second subject, that is engineering design and computer aided design. So this snap box that I have made using the Autodesk software. So you can see the whole model. This is the anti-theft alarm circuit. This is the whole model. You can see below also. So this is the whole project. I hope you enjoyed watching this one. So I hope you enjoyed watching my project model. So thank you very much for watching this video. Now, very special thanks to uh, my professor, that is Chandra C. Parmar, who is the head of department of the Information and Communication Technology at Marwadi University. So he guided me in this project. So I would like to thank him. Now this project was made by me, that is Harsh Sitpura. So I hope you enjoyed watching this video. So please like this video and share knowledge. Thank you very